Hello everyone and welcome back. So in this video, Lee's going to begin implementation of the Simplex 3D noise. This will be implementation part 1.
Right. There's going to be quite a bit that we're going to have to modify to make this work in 3 dimensions code-wise. But we are going to start, just like we did so many other times, by copying the 2D implementation and then pasting it and going through and making changes to modify it to support a 3rd dimension. So we'll bring in a float z argument. Now we're going to need 4 noise contributions, so we're going to set up N0, 1, 2, and 3, not 4. And we're not going to rely on this F2 variable before. And, well, actually, we made it a constant. In the 2D, we had that really weird, or not really weird, but the equation that relied on the square root of 3.
Mm-hmm.
Well, in 3D, the math is a little bit simpler, so we don't need to rely on a power 2, but we are going to hard code in a conversion factor. That factor is going to be all 3s, because the conversion is 1 divided by 3.
Okay.
So I'm going to put in 1, 2, 3, 4, 5, 7. 7 places of precision. So that will be our conversion factor for this one. Now, G2 is going to be used multiple times, so I will make a variable for this one. So this will be var and G2, which will override our other one. And this one will be 1666667, which is 1 6. So 1 divided by 6 to get this one. And this is our factor that we need to multiply I plus j plus k, which we don't have yet, so we're going to add that. So var k, which is going to be the floor of z plus our skew factor from above. So our unskewing factor will be I plus j plus k. And I'm going to modify this to be G3 instead, because I don't want to rely on just hiding. So I'll use G3. So that will take care of the first part of this.
Any modifications in the in var s where you're just using x plus y?
Oh yeah, you're right. D plus C. Good catch. Yeah, it would have looked just really weird. Alright, now we need to add the extra dimensions for this one, which will be capital Z0, which will be Z minus T. Small z0 will be z minus large z0.
Actually, z0, not y0. Okay.
And then we're going to need some more placeholders for calculating which simplex we're going to be in. So this will be ints of I1, J1, K1, and we're going to have a second set as well. This will be I2, J2, and K2, because now we're looking at 3 dimensions. The complexity of figuring out which simplex we're in is going to be a little bit more complicated, because now we've got the possibility of being in 6 different simplexes as opposed to being in one of 2 simplexes like we were in 2-dimensional. So where we've got this whole section here, I'm going to delete that out, and we're going to write a new section for determining how or which simplex we're going to be in. So we're going to check if x is greater or x0 is greater than or equal to y0. Then we're going to do some more checks and set some values. Else we'll run through the second set of parameters. Now inside the first set, we're going to check to see if y0 is greater than equal to z0. If that's the case, we're going to set I1 to equal 1, J1 equal to 0, K1 equal to 0, I2 equal to 1, J2 equal to 1, and K0 equal to 0. I really did want that all in one space. I did not want those all stretched out. So thank you, IntelliSense, for doing what I didn't want you to do.
That's not going to be IntelliSense doing that. It'd be ReSharper.
Is this ReSharper that's doing that one? Okay. I'm still holding something responsible because it wasn't me. All right. So that will be our first check. Else, if x0 is greater than or equal to z0, and we're going to be setting these same values again, so I'm going to just copy and paste these. But we're going to set different values. So we want I1 set to 1, J1 to 0, K1 to 0, I2 is 1, J2 is going to be 0, and K2 is going to be set to 1. And then our final condition, excuse me.
Bless you.
Cough. Had that tickle and I just couldn't help it. So, but, all right, third one will be I1 is 0, J1 0, K1 will be set to 1, I2 is set to 1, J2 is set to 0, and K2 is equal to 1. So we'll copy these three now, paste them down here. Now these conditions will check if y0 is less than z0, if x0 is less than z0, and if you're wondering what all this is, as far as where I'm getting the conditions, we're basically checking these, and then we're setting the values to mark which one we're in. So these are the checks that we're doing. All right, so our first set will be I1 set to 0, J1 set to 0, K1 set to 1, I2 set to 0, J2 set to 1, and K2 set to 1. Next up is I1 0, J1 to 1, K1 still 0, I2 will be 0 instead of 1, J2 equals 1, K2 equals 1. Then our last one, I1 will stay at 0, J1 will equal 1, K1 will equal 0, I2 is 1, J2 will be 1, and K2 will be 0. So we're basically, one way that you can look at it is we're determining which one of our simplex points we're turning on. So each one of these are marking one of 3 possibilities. So we've got three of these values set to 1, 3 of them set to 0. So that will determine which simplex we are in. Once we've done that, we need to do some more calculations so we can get ready to determine the gradients that we're going to use. So here, these calculations will pretty much be the same, but we need to change G2 to G3 for each one of these. And we need to add our third component, which is going to be Z. So that will be Z2 is Z0. All right, so now instead of -1, we will do minus J2, or here's I2. This one will be J2. This one will be K2. And still the plus 2's. We need to duplicate these. So this will be X3, Y3, Z3. This will be 1.0F, 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 and plus 3 instead of plus 2 on these ones. So these will give us our offsets for each of our 3 corners, or for this one will be our X, Y, and Z for our second corner, our third corner, and our fourth corner. And we've already got our first corner, which is the X, Y, and Z zeros.
Mm-hmm.
So that will give us all of our corners. Now, when we come back in the next video, we'll tackle the modifications that we need to do down here, which is going to be getting our gradients that we're going to use. So we're going to need to get some additional, the additional gradient for our fourth point and add in the calculations for that point, and then modify our blending of those 4 points together to get our final point.
Okay, awesome. Well, with that, that is going to wrap up implementation part 1. We'll see you guys in the next video. Thanks a lot.